No kind of. Okay. So cold working requires a lot more processing. That is basically a kind of time is getting consumed. Where in the case of cold working has better mechanical strength. That is the main advantage of these. Recrystallization. What is like working above recrystallization means what? Working below recrystallization means what?
Strain hardening below plastic deformation strain hardening.
Strain hardening, okay. Further, any idea? Just pick a recollect. Tell me right or wrong, I don't mind. I just want an interaction.
Meaning that its maximum temperature before it becomes permanent.
Before it becomes permanent means you are talking about before it becomes process resistant. Okay.
Below recrystallization means we change the properties of the material. Above the recrystallization temperature means we change the material shape and properties also.
Yes, actually it is more or less about the properties actually. So if we see like every material, every metal will have its different kind of properties and all, but here what happens is we often see all the materials and metals are made up with some crystalline structures. If you just recollect your science, physics, and this one, engineering, you would have seen something called BCC structure, FCC structure, crystalline structure, right? Next, HCP structure, hexagonal closed pack structure. So it is of that kind of structure. But what happens is at a particular temperature, means like we are working at a particular temperature, this crystalline structure is getting changed from BCC to FCC. Phase central TP lattice. What is central TP lattice? Is getting changed to phase central TP lattice. Means like here what happens is maybe it may lose some part of its term using that particular temperature. So crystallization basically conversions are happening from structure to structure. Because of that, we may like the sheet metal process symbol, we can work out little faster. We can work out little smoother. Otherwise, processing a sheet metal we will talk about no high amount of pressure. So sheet metal processing method in terms of basically rolling operations. So we have hot rolling, cold rolling. So someone asks a question for you. How you differentiate basically hot rolling process and cold rolling process? The only answer you can, simple answer I can say, that is working above the recrystallization temperature. We are working above recrystallization temperature in order to make our work faster and smoother. And cold rolling is what we are working below recrystallization temperature. Maybe we may apply some heat also, but it is not beyond. Now you can tell me at what particular temperature, if you are working on steel, when we can see this change, structure change at each temperature. You just recollect. What is melting point of steel? Melting means completely it is becoming like more or less in a waterfall. 1540 Celsius. One of your friends has given the answer. Any other answers you have? What temperature steel is becoming like water? 1000 degrees centigrade. Okay, still you can come up anything. Don't hesitate. Any other answers? 1570. See, Sayed is still more adding 30 degrees there.
1148.
1148 is another structure. So actually, melting point for steel is somewhere 1540 degrees centigrade. That again will be a point of interview question for you. It means steel is getting melted at that particular temperature. So beyond that, lower to that temperature, it may not be melting, but it is becoming smooth. But more or less, 1540 degrees centigrade is the temperature of steel. Now, crystal BCC structure is where you are working below its temperature, 727 degrees centigrade. Means if you are working above 727, then it is called as hot rolling process. Because change of structure is becoming. Like every material, it has been considered they have crystalline structures like BCC, FCC, HCP and others. So So steel is getting changed to DCC structure. SCC structure. So that change is happening at this particular level. So nothing about this temperature. In simple answer, nothing about this temperature. Okay. So plate and sheet. Plate and sheet. How you can differentiate? Usually, like whatever we are working, if we are with the thickness of the is above 6 mm, then we consider that as plates, and if it is less than 6 mm, then we consider it a different design. Top die is made with a different design, and the bottom die is trying to push it, so that you are trying to apply the shape like this, and again you are having one more different set of die. So finally you are trying to bring it out, and the outcome is it is some kind of inlet. You are trying to convert basically a normal load forming. So each station how it is happening. You can see basically in this station bottom die is different and top die is different. It is also acting like a ruler kind of. Road station 4, road station 5, and explosive forming. What is this one? Explosive forming, if the thickness of the sheet material is more, processing a sheet material of 5 mm, 6 mm is not that easy. Hydro forming, you can visualize intricate shapes, but if the shapes are bulky, the shapes are bigger, it is not possible by other process and all. So explosive forming will be a better option that particular cases. Simply how explosive forming will work out. So you have an explosion like a bomb, the water, and it is trying to create an explosion, and thereby what are the plate is there, what are the sheet is there, that is acquiring the shape of the die when you solve this particular process. Let me see the applications of this. You see? Some kind of bigger items, bigger vessels and all, if you wanted to create a sheet metal, then more or less kind of decorative pieces or something like that, you can create when you solve this process. Sheet metal operations, you can please take down the shearing, blanking, punching, trimming, parting, splitting, notching, perforating, nibbling, shaving, cut off, dinking, and fining.